All right. Take a picture.
So Facebook can use James Atropa and it's free for him more. No, I will give you his number. James Atropa. AKYE. And the YouTube. Use my radio. Open the permission.
Hmm?
The permission or
And you have 2 minutes.
Take the number 0243 183 960. Yes, but we are like, for one also, we pushing YouTube them out. For one also, we don't say, it's because I have to change permission. No? Yes, I hear you. Because of permission, it's not you about my sister. So, okay, one, so you see it. But you push it legally about.
We are talking to the lab.
May certainly, you send a link. Abba. Yeah, we are live.
Welcome, welcome. Yeah, we are grateful to have you with us.
Yeah, so you're all welcome to our first session of our audio training. For the purpose of our training today, we are going to go through the basics of sound engineering. The basics of sound engineering. And within these 45 minutes, we are going to do our best to capture the very little things that we take for granted as sound engineers. Sound engineers. And we believe these things would actually help us to better produce a good sound to feed our audience. If you see around me, I have a whole lot of instruments around me. And all these things are things that we actually work with. To begin our lesson today, someone would ask, who is a sound engineer? Or who would we refer to as a sound engineer? Reading a lot of books and meeting a lot of people, we have come across a wide range of definitions for sound engineering. And people who handle these equipment. And they have also been given a lot of names depending on where yeah, so we want to look at the duties of a sound engineer, equipment available to us to work with in the first place. Okay, so who is a sound engineer? Who is a sound engineer, or who can we call or refer to as a sound engineer? And the little that I gathered from the net reads as a sound engineer, also known as an audio engineer or a recording engineer. Someone who helps to produce a recording, but for the purpose of our seminar, we are limiting ourselves to live performance. Live performance. So someone who helps to produce a live performance, balancing and adjusting sound sources. Balancing and adjusting sound sources. And the sound sources we all know is the various sources from which we get our sound feed to work on. It's like that is the market, that is the raw market where we go then and then we do our picking. Just like if someone wants to prepare a stew, soup, the person will go out there and then scout ingredients. So you pick a little pepper, a little tomatoes, onion. Yeah, so all these are the sources for which the person will use to produce the food. In the same way as a sound engineer, once you sit behind your board, there are certain sources from which we get our raw materials to work with. And these sources are probably, it could come from voices, it could come from instruments, and a wide range of sources from which we get our sounds to work with. So once you are an engineer, it is your duty to sample from all these sources and mix it in such a way that it will be palatable to the ear. Just like a cook would have to mix all these ingredients nutritious, so that when you eat, you'd be satisfied and then tell yourself that yes, this is a good meal. The same thing happens with sound. You should be able to mix them in such a way that everyone will be comfortable in taking and tasting it, whatever you have produced. So our seminar is basically going to be around just these thematic areas, how we will be able to bring a lot of sources, sound sources together, mix them in such a way that people who listen to us, our audience, will be comfortable listening to us. So that is the whole idea of our seminar today. We'll be looking at duties of a sound engineer. Duties of a sound engineer, which I have put together duties of a sound engineer, which I have put together in 3 different areas. So a sound engineer is responsible for A, assembling, B, operating, and C, maintaining the technical equipment used to record, amplify, enhance, mix, or produce sound. So our core duties are these 3: assembling, operating, and maintaining. Assembling, operating, and maintaining. So assembling. What are we assembling as sound engineers? What are we assembling as sound engineers? Just as I indicated and then gave an example, just like a cook would have to go out there and then put ingredients together, the same way a sound engineer is supposed to put sound sources together. So for our core duty, every sound engineer, everyone who refers to him or herself as a sound engineer, is supposed to assemble devices, equipment within which work with. So you go out there and casting our eyes around, there are so many equipments around us. There are so many equipments. So we should be able to assemble the right equipment for your audience. Every program has the kind of equipment that you can use. Every program. So as a sound engineer, you're supposed to assemble these resources. And once you have gathered all these resources, that is the first thing. 2, you should be able to, if you go out there and then you buy a mixer and you are not able to operate the mixer, then you are not a sound to operate the devices. And then the third and one crucial and important duty of the engineer is also supposed to maintain them. We really have a problem with maintenance. It's an issue. You should be able to maintain the devices that you have, because if you don't maintain them, one, they will wear out easily. And once you start experiencing that, there are so many issues that you are going to face, especially when you are in a live setup where you don't have for try and error. It means that all the equipment that you are assembling, all the equipment that you are operating, you should be able to maintain them efficiently. So once you are able to do this, then we can comfortably consider you as a sound engineer. We can comfortably consider you as a sound engineer. Before we continue, viewers, you can also reach us on our Facebook page. You can reach us, and also on YouTube, Brainbox, or Enimdako on that page, and then on Facebook, James Achuka Jr. on that page. You can leave your comments. So whatever comments that you have, you can post it there, and then we will reach out to you. So as we are saying, duties of a sound in this equipment that we work with, most of these machines are high-end, costly devices. They don't come cheap. So if you don't maintain your devices, it becomes difficult. It becomes difficult working with them. It becomes very difficult working with them. So all that we are going to discuss is how we'll be able to use these machines efficiently. We are doing this training in phases. We are doing these phases in phases. We are doing it in phases. So the first phase is actually going to be more of introductory part. And then once we are done, in subsequent sessions, we will delve into very deep devices. Very deep devices. Okay, so just as we are still progressing, as a sound engineer, what are some of the devices that are available to us? Some of the devices are, one, there are so many of them, so many of them. There are so many of them. And if you cast your eyes around, you see I've displayed a few of them. We have mixers, amplifiers, amplify, we have processors, we have connectors, and so on. All these devices are available for a sound engineer to work with. All these are devices that are available for us to work with. Okay, so these are a few examples of the devices that we have captured. These are a few examples of the devices that we have captured. So you can see microphones, you can see speakers, you can see keyboard, mixers, guitars, you can see processing units and all that. So all these things are devices which are available to us, and it depends on your setup and where you are working with. There are some setups you wouldn't need all these ones, but there are certain devices and setups you need a lot more of these things to make that setup successful. And during this course of the seminar, there are certain terms that you should be very familiar with. You should know. We would try to explain most of them as best as we can. And the list goes on and on. These are not just the list, they go on and on. There are so many terms that you should be able to explain. At least you should have an understanding what they mean. That's the only way you'll be able to operate most of these devices, because these are found on most of the devices. You should be able to explain most of them. So as time passes by, in our subsequent sessions, we'll be explaining most of these words to us. Okay, so the focus of our study is actually going to start from here. What makes a good sound engineer? What makes someone a good sound engineer? So, what makes someone a good sound engineer? Most often than not, you notice that, yes, we have a lot of people who are able to sit behind devices. They sit behind a mixer, a small amplifier, and then, tune a few things. But when there's an issue, that is where it exposes them. And your ability to detect an issue and then the time you take in resolving the issue, it's what makes you distinctive from other people. In other words, if you call yourself a sound engineer and there's an issue during a live performance, one, the steps you would employ to detect the fault. Two, the measures you put in place to resolve the fault is what makes you a good sound engineer. So our seminar is basically based on these things. It becomes sad when there's a live performance and issues come up. For instance, one side of the speaker goes off, and you approach whoever is controlling the sound, and he's like, well, I don't have any idea. I don't know why it's off. You see, but then, because we are using systems, that is one thing that I would want to establish. We are using machines. Machines can behave funny at times. No matter how prepared, how tried and tested you have taken them through, they can disappoint you because of a lot of dynamics which come to play when you are actually on the live performance floor. But then as an engineer, once these issues crop up, there are certain steps that you have to employ, certain things you have to go through to address the issue. That is what makes you a good engineer. If you are not able to, and if there's an issue and for quite considerable number of hours within the performance, you are not able to resolve it, then you are not an engineer. Probably you are just someone who is able to, push a few buttons and all that. You are not an engineer. So our focus of this seminar is actually grounded in troubleshooting, how to troubleshoot and resolve issues. Secondly, you should also know that once the engineer, you are not able to resolve some of these issues, you then put your actors, your performers, those who are performing, those who are producing your source, your sound, you actually put them in a tight corner. In most cases, they end up messing up, not because they have not rehearsed or they have not planned, but because you, the engineer, the controller, you are not able to resolve the issue that came up, so they could also flow with you. And one thing that we have, or I have noticed per the experience I've had, is it is obvious people don't even know what they are using. That's the first thing. In a very complex setup, where you have a lot of libraries flying, a lot of amplifier, crossover units, a lot of buyouts and DI boxes all over the place, if you, the engineer, you are not able to detect where each device is and what each device is doing at any particular point in time, that is one thing which will always give you up. So the speaker goes off and you don't even know where the speaker is picking the audio source from, where the speaker, whether it's a powered or a passive, then it means you don't even have control of your setup. You don't have control of your setup. So as a good engineer, the basic thing that you always have to is to have control every device that you are using. So we'll delve deep into it. And then see what that we can do in terms like that in resolving certain issues. Per the experience that we have had, or I have had with live sound performance, I have categorized all the devices that we use, all the equipments, all the machines that we are using to three main areas, just like a typical computer. So we have input devices or equipment which feeds us with the audio source. They actually capture the audio source and then send it over. So all these devices which are able to do that, we have classified them as input devices. And then secondly, we have, just like a typical computer, we have processing devices. So once an input device is able to send an audio signal to you, then it gets to the second stage within the production line where we process the sound. Process here means it is at this stage that we are able to EQ, we are able to compress, we are able to put limiters, gate on it, we are able to normalize frequencies and all that. So all these things that we do to the source of sound that we have done, we are processing the sound. And there are devices which help us to do that. So once you have done all this and then you are satisfied with what you have done, it's just like a stew. You now dish it out to your audience. So dishing it out, it goes through an output device where the audience comfortably sits within an auditorium and then enjoy what you have processed. So if an audience raises an issue that you have a bad sound, then it means that it's either you have an issue with how you capture the audio, or the stage within which you processed it, or the devices by which the sound is being fed back to them. Just like a typical cook. You go to the market, you buy ingredients, you come to the kitchen, you process it, you add stuff to turn it to something else, and then you dish it back to them. So when they eat it, and then they are like, yeah, they are new idea. Sometimes you can enter someone's auditorium and the sound you are hearing is just like you are playing a CD. You're like, wow. Then it means that whoever is handling the sound must have done something right at each of these stages. At the early stages of capturing the audio signal, or the processing stage, or the stage by which they are fed back to them. It's just simple. Once you miss anything within these stages, trust me, you are not going to have a pleasant sound. Once you miss any of these stages, so at the very point within which we are capturing the audio signal, very, very important. And then the stage where we process it, we add effects and all that, very, very important. And then the stage by which we also feed it back to them, the means, very important. Any of these 3 stages, once you miss it, it's going to affect the quality of your sound. It is not magic. It is really going to affect the quality of your sound. So we are going to look at some of the devices which help us at each of these stages. And that is what is going to constitute our setup. So we are now going to delve deep into our basic setup. Basic setup. Okay, so into our basic setup. Just as I've explained to you, for a typical setup, every setup which we do for live performance, you should have identified any of these 3 stages that I mentioned. The initial stage where we capture input, and then the stage where we process these inputs. And then the 3rd stage, or the final stage, where we actually feed it back to our audience. These 3 stages, that is going to make up our basic setup. And when we mention the word setup, don't have that big imagination where you're having 10,000 speakers with 200 amps. No. It could even be just one powered speaker with just one microphone. And that makes up a complete setup. So if you have one powered speaker with just one microphone, it is a whole setup. So the microphone is going to serve as the device to capture our input. And the audio source could be from any of the instruments. It could be from voices. So the microphone is now serving as the device to capture our input. So when we have captured the input in just a single powered speaker, it goes into the speaker, and when you check most of the powered speaker, they have their own EQ. You see some high, low, mid, you see volume control, some of them you see low cut, high cut, all that. They are supposed to help you treat the sound, even in that particular box. And once you have worked on those sounds with your frequencies, you are okay with the gain, the volume and all that. Now you push it back through the speaker. You push it back through the speaker to whoever is listening to you. So just one powered speaker is a complete setup. Just like we'll have a very huge setup. Where you have a mixer, you have a crossover somewhere, you have an effect in your processor, speaker management system. They all make up the setup. They fall within either an input device, a processing device, or an output device. And once you are able to detect what each of these devices is doing at any point in time, that is what gives you control over your setup. And one thing that we have noticed, or I have noticed going around, is I have always been questioning a lot of engineers why they don't actually put down what they have on stage. Why don't they do that? What we call the sound drawing. Very, very important. In fact, it is the first thing every good sound engineer is supposed to do. Sound drawing. Now, what is sound drawing? Okay, so you have a performance. For instance, you are supposed to do a performance probably at National Theatre on their stage. So as an engineer, you are supposed to go there and then check the arena, what we call recce. You are supposed to go there and they detect every point that you are going to place every equipment. So once you have imagined that I'm going to place my front of house speakers here, I'm going to place my subs here, I have monitors here, the performance are going to be here, I have BVs here. Once you are able to do that, theoretically, now put that same thing on paper in a form of a little diagram with just a few details, so that even if during the performance things go wrong, there's a BV might go, even before going there, you just pick your drawing and you know that no, the BV was not supposed to be there in the first place. It means something must have gone wrong. And these are the very little bits that will help engineers to always have control over their sound. We'll have an extensive lesson on how to draw a very comprehensive lesson audio diagram. It is very important. It is very, very important. Just like an architect would draw, a floor plan, put this, I'm going to put a nail here, I'm going to put a wire here. The same thing happens to a sound engineer. For every setup, even if it's just one speaker that you're going to place, you need a sound drawing for it. You need a sound drawing so that you are able to, and one thing that it also helps is probably in your absence, you are there and something comes, emergency, you have to leave. Whoever is handling sound in your absence, per the drawing that you have provided, is able to carry on from where you have left off. But if there's nothing, now you see, it becomes difficult, especially when you have an analog mixer where they have been writing so many things on it. It becomes difficult for the person to detect what is going through channel 1, what is going through, where is the BVs coming from, which auxiliary is the BVs going through. It becomes difficult. But once you have a sound drawing, the person goes through it and is able to, even without going through the performance, is able to tell that from hindsight, this is what we are dealing with. It is very important. So I'm advising all our engineers, all our would-be sound controllers, you have to learn how to put your ideas on paper. Put your ideas on paper for every performance, every setup that you do. Put it on paper. Every setup that you do, no matter how big or small the setup is, put it on paper. And that is the sound drawing with a little details, a little legend for someone to know that if you see L might mean that it's a left stereo, a right stereo, you are playing mode for sub and all that. All these things, you have to put it on paper. It is not any big book, just something little, which will serve as a guide to yourself and then other people also helping you up with the setup. Very, very important, the sound drawing. So I'm going to show you a few of the diagrams that we have developed over time so that you'd see what we are going through. A few of the So on your screen right now, you are supposed to see a few examples of the setups that we have been doing over time. You see we have two powered speakers with a mixer. And then the mixer is being fed by microphones. The microphones, we can also have keyboards, we can have guitars, we can have voices also singing. So they are serving as input devices which will capture the audio signal, which will actually transfer audio signal into our powered speakers. And then once it comes through the mixers, that is where we more like the factory, we work on it. You do a few processing, a few EQ, all that, and then we push it back into the speakers for our audience to also enjoy what we have done. And this is an example of a little bit complex setup. Just as I explained to you, the setups differ depending on your setting or your location. Because the setup that you do in a small auditorium, which takes people like about 50 seating capacity, I don't think you do the same setup for an auditorium which takes like 1,000 people. You can't do the same setup. So the audience, the auditorium, the setting also affect the kind of setup that you are going to do. So this is an example of a typical complex setup where you're having a lot of audio signals. We are picking a lot of signals. So we are picking about 3 guitars, we are picking bass guitar, we are picking about 4 keyboards, we have the drums, we have percussion. All these are sound sources that we are going to pick and then push everything into our factory. And this place, our factory, is the mixer. The mixer, and that is the point where we are going to work on them. We work on them, and when we are satisfied with what we have done, we now push it back to the audience. And pushing it back, we can push it back through the monitors. For those who actually produce this, who also enjoy what they are producing, then we can also push it out to our audience, what we normally call the front of house, the front of house sound. Then we push it back to them so that they would also enjoy what we are doing. So all these things are an example. Now to your extreme right, I have done a little drawing. So this is a typical example of a little sound drawing. And this sound drawing is indicating what we call the audio routing, how we have routed the sound. Routing here means that the channels by which we have sent the audio signal. So we picked it from a microphone, and then we have sent the microphone all the way through probably a crossover or a mixer. And then the mixer goes through a crossover then pushes back to the speakers, and then pushes sound back to the monitors. So this is an example of a complex audio diagram. I'll be showing you a much simpler ones. This is also a typical example of a live stage setup where you are going to have your devices placed within the auditorium. So you see a lot of diagrams, or that everyone representing something. So this is a typical diagram for a live band setup. A typical diagram for a live band setup. Just as I said, we'll have an extensive lesson on how to draw a typical diagram. So you better appreciate what you are seeing there. I know it's going to be a little bit cumbersome, but once we take you through how you'll be able to put an extensive diagram there, you find this thing interesting. Okay, and this is just like a simple one where we don't actually use, we only use just a little diagram. You get a pen and paper and then put. So you see the diagram from the diagram, you're able to tell where your mixer will be positioned. From the diagram, you'll be able to tell where your BVs are, where your monitors will be positioned, where you are going to have your effect units also placed. And all these things, you then push everything. So the diagram tells you with arrows where what is coming from, and then the channel by which we are letting these things out. The channel by which we are letting these things out. So before we even continue with our sound setup, just as a viewers, you can still join us. Send your comments to the Facebook streaming pages, and then we'll address them. We'll address these comments. Now, I have here a couple of the devices I've been able to sample, which I would want us to go through. They are the normal devices that I know you are used to. I know you have a lot of them. This is a typical mixer. What normally people call the analog mixer, because we have other mixers, digital mixers, live stream mixers, and all that. So this is a typical analog mixer. And then all these things that you are seeing, they are individual devices. This is an effect unit, a lexicon effect unit. You are having a crossover. This is a typical crossover. All this is our devices. This is also a typical crossover. You are having a graphic EQ. You are having all these things are effect units. You know, in the olden days, before technology keeps advancing, when you are using a typical analog mixer like this one, there are certain effects, certain parameters that you will not really find in these mixers. That is how come you then need an external effect units, like these ones, to help you to get certain effects. But these days that we are having digital mixes, most of these effects are embedded in the digital mixer. So once you get your digital mixer, you are fine. You might not really need all these effect units, except you want a certain particular effect unit that you might not find in that brand of mixer that you are using. But apart from that, all these ones are now embedded in the digital mixer that we are having. Almost all these things are embedded in it. And they are the very devices that I explained initially, that they help you to process your sound. They help you to produce a sweet sound. So if you take a raw signal, a raw voice through a mixer without any effect, nothing, and then you do a second one with effect on it, with the processed sound, you notice that the output you are getting will not be the same. Your output will never be the same. Your output will never be the same. Once you process the sound, you add things to it, you notice how sweet the sound will be. And that is one mark of a good sound engineer. One mark of a good sound engineer. Once you're able to, just as I explained initially, if you know what these devices are and how to use them, that is the operating stage. So after you have assembled all these things, you have gathered all these things, but you are not able to use them, you don't know how to operate them, then it means you are not a good engineer. You are not. You are not. So the focus of this seminar is to help. There will be further ones how to use most of these things. When you go to YouTube, there are a lot of videos. A lot of videos how to operate these things. What might be the challenge is maybe the terminology, the terms they might use. Maybe gate here, cut, boost, perceive, words and all that. Yes, you might not understand, so it will give you a challenge as to how to use these things. But once you know what they are, and then you understand the terminologies which goes with these things, you find it very interesting using them. You find it very, very interesting using them. You find it very, very interesting using them. Yeah, so just as I have explained, so this particular lesson is introductory lesson. Okay, so I'll take the next 5 minutes to answer a few concerns that have been sent over. Now, someone asks, how will you treat feedback with all these complex devices around? And it's a question that I get a lot, especially when we go for location performance. We often get a lot of these things. Feedback is an issue that a lot of engineers have still not mastered the way to deal with them. And just as I explained from initially, it all depends on, one, you having control over your setup. If you have control over your setup, it becomes difficult, it becomes very easy to detect what is actually producing that feedback, and then you are able to resolve it. All these things, feedback, it actually hinders on frequencies, which will be a subject that we are going to treat deep next time. Frequencies. It is a frequency which is at play, which is having a resonance, that produces feedback. So in the first place, if you are an audio engineer, sound engineer, and you don't even know your frequencies, we have a wide range of frequencies perceivable to the ear, from 20 hertz to 20,000 hertz. That's the range. So within all these frequencies, as an engineer, you should be able to detect which frequencies are resonant. You know, they keep repeating themselves. They provide the feedback. So once you're able to detect that frequency, it becomes difficult limiting it, reducing it with the help of your EQ, either your paramagnetic EQ or your graphic EQ, which we are going to look next time. We are going to discuss that next time, the difference between a paramagnetic EQ and then a graphic EQ, and how these EQs are used in a live performance, the scenarios, the situations where you use these EQs. They are very important. So with the issue of feedback, the first thing, just as I was saying, you first have to identify which frequencies are creating that. And before you will be able to tell the frequencies, you must have measured, must have detected the frequency with a device. It is not just by the ear. We have devices like the RTA, real-time analyzer. It's a device that you can get, which I would recommend every sound engineer to get. Once you have that, it becomes very difficult. So once the feedback starts coming and then you activate the RTA, it will tell you which frequency is doing that. Once we eliminate it, it's gone. It's just like magic. It makes it easy. It is when you don't have it, now it becomes difficult, now using your ears to now detect whether you're having somewhere 4K and 8K somewhere, a 3K doing noise, a 200 Hz and all that, so that you can eliminate them. So once we eliminate those frequencies, the feedback will also go off. The feedback. And then we also have another concern. The person says he's using an analog board, but he wants to have all these effect units in the board, which I wonder how the person will be able to. But what we have experienced is most of these boards that we have, the analog ones, they have a specified template for effect unit. So once you have them and you still want to use that particular board, it means that you are limited to that effect unit. Or you can get an external effect unit, just like these ones, and then route your signal through the effect unit before going through your faders. So we'll be looking at all that, what we call faders, what we call buttons, what we call knobs and all that, and what they are used for in all these boards. So it's very important. If not, then you have to get a digital board. Fortunately, most of the digital boards that we have, they have all these signal processors and all that embedded in it. Most of the advanced ones are even having speaker management in it, where you can actually configure the sound you are getting from your to specific speakers, which I think is a good thing. So you just have to check on that. And then the last concern that I would address is I know it's a general question, that the person asked that he visited a church and then the sound he was hearing, he has tried replacing, producing the same thing from his end, but then he's not getting it. So what is he not doing right? This is a question for the gods. What is he not doing right? In the first place, ask yourself, are you using the same equipment that the person is using? That's the first thing, because I explained to you that to produce a very good sound, there are three things that you have to consider. Your input devices, very important, your processing devices, and then your output devices. If at any stage within these three levels you miss one, your sound will be deeply affected. If you want a good sound, it means you have to get a good source of capturing this sound, and then you have the second one, the processing, and then the output. So if you are not still getting the desired sound that you are yearning for, then you have to check the devices you are using at each of these stages. You have to check the devices you are using at each of these stages. So once you are able to check, then you'll be able to actually have control over what you are producing and then what you are not producing. Just as I said, time is almost up, but this is actually an introductory seminar on sound engineering. It's a whole program, it's a whole course that we always take people through, that we always train people on how to use their devices and all that. We are going to have these sessions in phases. We are going to have them in phases so that you'll be able to appreciate your job as a sound engineer. You'll be able to appreciate the role you play in providing a sweet sound. Sometimes it's so sad, sound engineers in churches think they are not so much important. But trust me, you can mess your pastor up, you can mess your singers up. The whole service can be messed up if the sound engineer decides not to bring his A game to the show. The sound engineer can mess up if he decides not to bring his A game to the show. So sound engineers, we play a very crucial role in every performance. We play a very crucial role in every performance. Whatever we do, because if your pastor is ministering in the spirit and the pastor is there and then all of a sudden the sound goes off, you can just imagine the look on the pastor's face. You can just imagine the state within which you put the pastor. So once the pastor is ministering, whatever you are doing behind the board is very important. It's very important. And one thing that I have also noticed is they go to church, sound engineers get to church, they power the machines, everything is working, and bam, it's somewhere and then they are chatting. Trust me, you should be attentive because we are using machines. You don't know at which point your device will decide to go off. You wouldn't be able to tell at which point within which your machine will decide that today I'm off. And once the machine is off, it becomes the duty of you, the engineer, to bring it back alive. So we have to be very, very important, very, very, very attentive at any place. Very, very attentive. In conclusion, if you have challenges with your sound that you'd want us to help with, we help with training, we help with tuning devices and all that. I have left contacts on the screen that you can contact me on any issue at all, once it has to do with sound, live sound or studio recording sound. You can contact us and we'll always be ready to help you. Thank you very much and stay tuned for the next session.